All right, lastly, we have this little simple equation. It looks simple, right? It looks simple. I'm going to solve it for all x. Problem is, how can I get this in terms of just sine or cosine? And that's problematic. You know, I can't have one cosine, one sine, but I can't use any kind of Pythagorean identity or whatever else. So what I need to do is take this problem and square both sides. That is a strategy for solving equations, squaring both sides. Now, when you do square both sides, you have to check your answer. I'll write that as a note. When squaring both sides, check answers. Because some of them may be what we call extraneous. All right, so what do we have here? We got cosine x minus 1 times cosine x minus 1. And this is sine squared x. If I distribute here, combine like terms, I'll get cosine squared minus 2 cosine plus 1. And then I'm going to change this to its Pythagorean identity because I know that I just want to work with my cosines. So 1 minus cosine squared. I'm going to move these terms over here. Add the cosine, I get 2 cosine. Bring down the minus 2 cosine, subtract the 1, I get 0. Okay. What do I do here? I got to factor out the 2 cosine. So this is going to leave me with cosine minus 1. Then I'm going to set each factor equal to 0. Okay, so here, divide both sides by 2, you get cosine equals 0. Well, let me see about this one. Where's the cosine 0? Where is the cosine 0? Cosine is 0 here at pi over 2, and down here at 3 pi over 2. Now I need all of my solutions. It says for all x. I had to think about this for a second. So usually you could, what we've been doing is saying, okay, this one plus 2 pi, right? And this one plus 2 pi. But I can consolidate that. And if I wanted to, I could consolidate that and do this one plus pi, because that would give me here plus pi n. But I do need to check for extraneous solutions on both of those, okay, before I can do that. Over here, add 1 to both sides, and you get 1. Where is that? That happens at 0. Okay, so I need to check these 3 answers in my original problem. You have to check in the original problem, okay? Which is cosine x minus 1. Before you square it, you got to check it in this, okay? All right, so for pi over 2, let's check this one. Is the cosine of pi over 2 minus 1 equal to the sine of pi over 2? Well, let's see. What's the cosine of pi over 2? That's equal to 0. 0 minus 1 is negative 1. And the sine of pi over 2 is equal to 1. Oh, so this side gives me negative 1 and this side gives me positive 1. Y'all follow that? And so this one does not work. Okay, that does not work. This is extraneous. We can't use this one. This one is extraneous. Okay. Now let's check 3 pi over 2. Is the cosine of 3 pi over 2 minus 1 equal to the sine of 3 pi over 2? Well, the cosine of 3 pi over 2 is 0. 0 minus 1 is negative 1. And the sine of 3 pi over 2 is negative 1. So that works out. And now I got to check 0. Cosine of 0 minus 1 equals the sine of 0. Is that true? Cosine of 0 is 1. 1 minus 1 is 0. Sine of 0 is a 0. So this also checks out. Okay, so I have these 2 answers right here. And so one answer will be 3 pi over 2 plus 2 in pi. And the other answer will be 0 plus 2n pi, or I could just write 2n pi. Okay, that's the same thing. Okay, 0 plus 2n pi.